Welcome to the Multi-View Data Visualization lecture, part of the Principles of Data Visualization lecture series. In this lecture, we will discuss a number of multiple view methods for data visualization. We'll begin discussing multiform visual encoding. What does that mean? What does it mean to have data visualization encoded in different ways? We'll discuss shared visual encoding or common visual encoding, overview and subsets, combining multiple data layers, navigation, and then we'll wrap up with a large conversation on small multiples. So the first subject we need to understand as a part of multi-view data visualization is called shared encoding. And what shared encoding is, what it means, is visualization encoding of the data is the same. And so what we're looking at here is we have two different examples, one on the left and one on the right, with visualization encoding. So the one on the left that we've defined as different, we'll see a difference in the visualization encoding. So on the left-hand side of the different views, we see a bar chart. So that's one type of visual encoding. And then on the right-hand side, we see plotted points. So these are two different types of visualization encoding. Then if we look on the right-hand side where it says same, we see on both the left as well as the right, these are plotted points. So this is what we would call shared encoding. It would be an example of shared encoding where the visual encoding is the exact same for each of the view representations. So that also brings forward the concept of when we have different encoding, we refer to that as multiform. So that's multiform encoding. I'm basically just sort of highlighting that there are two different forms of visual encoding or visual presentation there, as opposed to our shared encoding. Now, extending this concept into overviews and subsets, we can have different or common encoding with overview and subsets. So on the left-hand side, where we've denoted different, we see as part of the overview is done in a bar chart or column chart visual encoding. And then the detail is done with plotted points. So we have that multiform different encoding there. When it's the same on the right-hand side, so we have shared encoding, both the overview as well as the detail is created in a bar or column chart type of visualization encoding. Now, we may wish to do some layering or create different layers or overlays data in the same visual frame. So this is called layered visualization, and so we're able to do this when we meet a few conditions. So when data contains the same variables, so as an example, in our image here on the left-hand side, in the green as well as the black frame, we have the exact same variables on the X and Y axis. We're basically representing the same thing. It's not, they're not different attributes or variables. They're the exact same variables. We also have to share the same visual encoding. So we have to have that shared encoding, and we do here. So we see on both the green frame as well as the black frame, we're using plotted points. So we've passed both tests there. We've got both boxes checked, and because we have the common or consistent variables as well as the common and consistent visual encoding, the shared encoding, we can then overlay these, basically layer these one on top of the other. So what we see here is we might begin with the green frame. We then place the black frame on top of it, and that becomes a single view with that shared encoding of plotted points. But we can see the two different views basically combined into a common view of layered visualization. Now there are also some additional techniques that may help us to review different views of data. So navigation is an alternative to a multi-view type of visualization or side-by-side multi-view that allows us basically to use navigation to proceed through a number of different views. And some of the different types of construction that we see here. First, frame-based data narratives. So these are the type of navigational presentation we might find in Story Points and Tableau. We might find websites that have this type of stepper navigation, and we could also find same type of frame-based data narratives in SAP Lumira. Second major construction type is animation. So we might create some type of animated data visualization. Typically that's going to be web-enabled, where we can basically engage multiple views to basically play through. And then finally, we can have video presentation, where we've in essence recorded multiple views of data visualization in a linear sequence. So now let's contrast the two. So we've discussed multi-view data visualization. We've also discussed navigation. And so which one do I use where? How do I know which one to use? So one of the first questions that we would ask ourselves to make this decision is, can the audience keep track of the data elements? So what we're trying to do here is determine, do I want to compare the still frames and take sort of a very dedicated view, sort of back and forth comparison and contrast view? If that is the case, the second question, are discrete side-by-side comparisons useful? If they are, then I might want to look at multiple view, or what we will call small multiples, that are equivalent visualization views presented side by side. If I'm more interested in looking at the change or the behavior of how, for example, how different variables change over time, that might be more applicable to something with navigation. So I might want to use one of those three different forms of navigation. And what the audience will be doing, sort of the main difference in the two, is with navigation, typically the audience is going to be reviewing the change or the process that's going on. When we're using multiple view data visualization, it's a very detailed compare and contrast side by side type experience that we're wanting our audience to participate in. So what are small multiples? So small multiples are similar to the frames in a historic film. And so if you've ever seen sort of the history of movies or film, you'll see that they have little frames. Often they had sort of holes in the side of the film that would help to drive the film forward, basically help the film to play. And small multiples are essentially little frames of visualization, just like those film frames, but they're presented side by side. So we will have these separate multiple views, and it's in order to call it a small multiple, we have to have at least two views, two frames of data visualization presented side by side. Now it can be many more than two, so we could present 4 or 8 or 16 or 30 of them or 50 of them. We could have a bunch of them on one view, but there has to be at least two that we're comparing. And so we create these separate multiple views and place them into the spatial regions of the screen. Basically, we fill up the screen or the canvas with these smaller frames to compare. Essentially, we are partitioning the screen and partitioning a data set based on the variables. So we may have different measurements, perhaps over time, or we may have differences in one of the variables like geography that we are creating these unique views from. And there has, for example, there has to be something different from one view to the next, some movement in one of the variables in order to really make a comparison. Otherwise, we'd just be looking at a bunch of small versions of the exact same thing. Now, in order to do small multiples, the visual encoding in each of the small multiples or small frames must be the same. And as you see represented at the bottom of the screen, they are both shared encoding plotted points. And this must be the case. In order for small multiples to work, where you can do a comparison on the same screen, the visual encoding must be the same. And the type of human process that is engaged here is our spatial processing. So what happens when we put these small views side by side that are the exact same visual encoding? We're basically looking at one frame and then comparing it to another frame. And what happens is our spatial processing and looking at the first frame sets a visual expectation of what should be. And then when we look at the next frame, our spatial processing is actually comparing that frame to look for differences in the first frame and the second frame. So what we're actually doing is using that spatial processing for comparison, and we're trying to find what's different. Why are these different? What's different about them? Why are they different? And we're using our visual spatial processing to do that analysis work. Now let's talk about some of the limitations of small multiples. So the first probably obvious limitation of using small multiples is we only have so much screen real estate. So we have to be thoughtful about how many comparisons do we make, how dense or how many data points are encoded, how many spatial objects are encoded in each one of the frames, because we only have so much screen. The second one is a limitation of the number of data elements that can be successfully presented. And to give sort of a simple example, let's say that we have a dozen different small multiples all presented on the same screen. So we have 12 different tiny little views that we're looking at. If we presented 1,000 different data points in each one of those 12 views, our processing becomes much more challenged because we're having to process somewhere around 12,000 different comparisons or 12,000 different pieces of space or objects in space that we're trying to compare. In contrast that with, let's say we have the same 12 frames and we only have 5 different spatial objects, 5 different plotted points or 5 bars. That becomes a much more manageable number of comparisons for a human or an audience to process. So we need to keep in mind that limitation of the number of data elements that can be successfully presented in each view. Now, what are some of the applications for small multiples? So what are small multiples good at? Just some simple business examples that this might be useful for. Sales by country. So I might be doing business in 8 different countries, 20 different countries, and I may want to look at the sales in the 20 different countries all at the same time, all in the same view. All in the same screen, but different small views. Sales by region. So I may have 50 different states that I want to look at sales comparisons in all at the same time. Or sales by geographic offices. Now, I wouldn't necessarily be creating views of the geography or maps here. I'm creating perhaps 20 different small views of bar charts or plotted points that represent the performance of revenue or profit for those 20 different offices. Same thing with sales by team. So I may have a number of different sales teams in a particular office that I want to put their performance in small views and have them all on the same screen at the same time. Or we could look at customer demographics. So any of these types of variables: age, income, zip code. There might be a number of different variables that we want to see a comparison for, all on the same screen side by side. So let's walk through a little bit of the construction of a simple, straightforward small multiple. So here we have a Tableau screen. We have two different data sources. So if you look on the top left-hand part of the screen, you'll see the data panel. And within the data panel, you'll see two different data sets. One for the flights database and one for the orders database. So we have those both presented there, two different data sources. Within each of those, we might rename some fields to blend the data. And in this particular case, we're interested in how this data can be compared over time. So as an example, we might do a data blending on the date field. And data blending is a technique in Tableau that's very similar to joining data sets. So many of the things that I'm saying you could also accomplish through a join. So let's say that I have these two different data sets. I have both flights as well as orders. And what we see represented here, we have in columns, we have the common months across the x-axis there at the bottom of the screen. So you see the different years. Those are divided up into 12 different equidistant segments that are the months, January through December. And then in rows, you'll see that we have both the sum of sales, which is basically the combination of our revenue, combination of all those orders, as well as the sum of flights. And we see that at the bottom of the screen. So we basically got two different views here, presented one on top of each other. They each have their own y-axes. So we see sales at the top, and we see the trend line, the pattern that's going on with our revenue sales. And then at the bottom, the y-axis that we see representing there is the quantity of flights. And we see the trend pattern for the quantity of flights that's booked. And then our curiosity, what we're trying to do here is we'd really like to see these overlaid on top of each other. So here in this frame, this is an example of a very simple small multiple where we're comparing two different views. Notice the shared encoding. So these are both sort of a line or trend charts, a type of encoding. Now, if we wanted to take a look at layering, here's an example of the exact same data, but in this case, we're doing layering. So we've taken those two previous views. So we had the sales as well as the flight trend lines. And we've created an example of dual axis view here. So you'll see on the left-hand side, we see the sales revenue y-axis. And then over on the right-hand side, you'll see the quantity of flights. That's the second axis, or the second y-axis. And then we've overlaid these, basically layered these on top of each other from the standpoint of time across the x-axis at the bottom. So 2007, 2008, 2009, etc. across the x-axis at the bottom. And here we can see, are there patterns in the two trend lines that are the same or opposed? We might get some sense of, are the behavioral patterns here somewhat correlated between revenue and number of flights? And so we might see some patterns here. We can see some consistency where the two lines run fairly close together. But then we also have different parts of these trend lines that separate quite a bit when we have these particular patterns. We can also see there's some unique insights that we might be able to see. For example, if we look sort of about 2/3 of the way through the year 2007, we can see that there's a particular pattern that if we have a decrease in the number of flights, we might actually have revenue that comes up and has a little bit of a spike up. And likely what we're seeing there is that we have fuller flights. So while we may have a lesser quantity of flights, if it's within a certain range and we filled all those flights, we actually have an improvement in revenue, an increase in revenue. And that's only going to be within a certain range. Obviously, there's going to be a strong pattern of more flights and more revenue, or less flights, less revenue. That's a general trend, what we might call a macro trend. The main thing I want you guys to take away from this view is the layering. Notice how we've layered two different visualization views on top of each other so we can see the behavioral pattern together in the same view. Now, proceeding on with our small multiple conversation, our multi-view visualization. So here's an example of utilizing that same encoding with the trend line, asking the question, well, what happens if I have 12 different categories? So here we're looking at quarterly information. So we have for each year, 2011, 2012, 13, and 14, we have those different years, time segments on the x-axis, and then we've also segmented by quarter. So if we look down at the bottom with the x-axis, we've split it into different quarters, quarter 1 through quarter 4, within each year. Then if we take a look at rows, we've brought in the segment, and we have unique segments here, the consumer segment, corporate segment, and home office segment, which are simply different collections or groups of customers. And our axis here, our measure, is the amount of profit for each of these groups that we have represented in the y-axis for each of these groups. And notice that it's the y-axis is the exact same for each. That's intentional and a requirement to have small multiples. So you'll see it basically runs from 0 with 3 different stated intervals at 5,000, 10,000, 15,000, and we still leave a little bit of space for that top line of 20,000 without the label. And notice that it's the same whether it's consumer, corporate, or home office. It's the same for each one. Has the exact same set of intervals and y-axes. And again, that is a necessary condition of a small multiple. Now, once we get all that set up, we can then simply compare the trend lines to see if we can find unique things that are going on. So we might walk through it with an analysis of comparing our 3 different segments in 2011. So we might see, yeah, it seems like across those segments there's an uptrend. We also notice in the corporate and home office that there's a little bit of this increase and then a hockey stick pattern for both corporate and home office. We might then look at 2012. So in 2012, in consumer, we see a fairly different shape, a distinctly different pattern in consumer versus corporate and home office. So in both corporate and home office, we see that hockey stick pattern, but in consumer, we actually see something more like a curve that rises and then drops off as the year progresses. We look at 2013. We might compare these. We see a little, maybe a little bit of commonality in a upward pattern in consumer and corporate, but we also see some commonality in the third quarter with corporate and home office sales that seem to both drop, and we don't see that same sort of drop in the consumer segment. Moving on to 2014, we have that same hockey stick pattern for home office. And if we look across from 2011 to 2014 in home office, we see that hockey stick pattern all across. So every year we see that. Moving up to corporate for 2014, fairly peculiar in that we've had 3 years of this hockey stick pattern with sort of strong growth at the end of each year, we see a distinct difference in 2014. So we really break off the pattern there. We begin the first couple of quarters with that strong growth trend, which is consistent with 2013, a little bit consistent with 2011, but definitely not consistent with 2012. And then it really changes the pattern and drops off mid-year and is unlike anything that's occurred before in corporate for the end of the year, the last 2 quarters of the year. Then for consumer, we see a V-shaped pattern that is also distinctly different than anything that's occurred before in 2011, 12, and 13. We've not seen this V-shaped pattern where there's a lot of drop and then all of a sudden we regain our progress mid-year. So this is kind of the approach that we might use to compare small multiples. This is a good example of small multiples side by side. You'll notice the shared encoding. Everything is a trend line here, and this is how we might go about doing some comparison. Well, what happens if we have 18 different categories that we have to compare? So here we have 18 different countries, and we're comparing the unemployment rate. And specifically, we're comparing the unemployment rate in the Eurozone. So these are all Eurozone European countries, with the exception of the United States. And we're comparing what is the unemployment rate. And the United States is included in this category because, for the most part, this data visualization was created for a U.S. audience. And so what can we do when we have a representation with 18 different categories? So here it's been represented with a trend line. We have time on the x-axis, which is what we would expect. We often expect time to be represented on the x-axis. And then on the y-axis, the percentage of the unemployment rate. And when we use percentages here, it has a normalizing effect, regardless of the different sizes of population in each of these countries. And they each have a different population size. Some are smaller, some are larger. But when we look at it with the percentage basis, it gives us a good normalized comparable, regardless of the size of the population. And so then we can see who's doing really well. So we see perhaps Germany is managing its unemployment rate, a fairly low-level comparison. So we see Germany's roughly at 6% there. We might also look at some other countries, the Netherlands, Finland. So they're in the range of sort of 10, 11% or under of unemployment. But then there are a number of countries that are struggling a great deal more. And if we look toward the top of the chart, along the timeline, about 2009, when the global financial crisis hit, we see some of these countries really get out of shape with the dynamics that are playing out in the financial crisis. Specifically, Spain gets out of shape pretty quickly, and the unemployment rate rises to 25% pretty swiftly in 2009, and then proceeds up all the way to a 35% unemployment rate. Basically, a third of the population is unemployed by 2014. In Greece, it takes just a little bit longer, so along 2010, 2011, their unemployment rate spikes up above 20% and then proceeds to a sky-high rate of almost 40%, or getting close to half of the country is unemployed by 2013. So distinct differences in countries, particularly for some of the most severe problems versus countries that seem to be managing it a little bit better. And then, of course, we have some countries that are in between. Portugal, Cyprus, Italy, Ireland, France, Belgium, all in the sort of under 25%, so somewhere between the 12 and 25% unemployment rate would be sort of our middle performance countries. Now we can also take a look at similar information. So we see that this is a very similar type of data visualization. It's looking at both unemployment rates as well as youth unemployment rates for European countries. But I also want to bring your attention to the usage of a comparable. So when you present a number of small multiples like this side by side, so we see, let's take a look at the one on top first. So unemployment rates, in general, we start with Austria, Germany, Luxembourg. We proceed across all the way to Spain. And it's going to show the trend line in small multiple form for each of these countries. Now, what we see layered in there as well, you'll see the light gray line. So that's a reference point. And what that's providing for us is what is the unemployment rate trend line or pattern for the United States compared to each of these countries. And again, this is because this data visualization is targeted toward a U.S. audience. It's provided by the Washington Post, so it's for a U.S. audience. But it's a U.S. audience that's curious, how does the unemployment rate compare in the United States to other countries in Europe? And so what we can do is we can proceed through each one of these comparisons. When we compare it to Austria and Germany, they both seem to be doing a little bit better overall. If we take a look at Luxembourg, they seem to be doing a little bit better. Netherlands seems to manage it a little bit better, but we seem to be sort of converging on the same point. Malta still performing better, but there's a point at which we get to, say, for example, France, Estonia, Slovenia, Italy, Ireland, where it appears that the U.S. is performing much better than these countries. The U.S. was able to sort of normalize this, turn the corner at that 10%, and start pushing the rate back down, where many of these countries were not able to do that, or it took longer for them to do that. And you see very large spikes in the unemployment rate up above 10%, with some of the worst, of course, in Greece and Spain that we had discussed before. Now, the second part of this view is the youth unemployment rates. And so this is a different cut of the data. So you can think about this as sort of a drill down or a refocus, a filtering of this data set to where it just looks at youth unemployment rates. And this is a particularly important topic because it has a number of different social impacts. Sort of the status quo or the norm historically is that we want our young people to become educated, then enter the workforce, and be some of the sort of highly creative, dynamic, innovative parts of the workforce that we've seen historically over time. So this is a particular area of focus that's of interest, and you'll notice that it's distinctly different. The pattern is distinctly different. So let's take Austria and Germany. So in the comparisons of the overall unemployment rate, it seemed like the United States was performing, pretty well compared to the two. But then when we take a look at this different youth cut of the data, we see a really different picture here. So we see, in this case, both Austria and Germany managing their youth unemployment rate, not quite as well as they do overall, but the trend pattern is fairly similar for the overall employment rate. However, when we compare it to the United States is performing very poorly in managing the youth unemployment rates. We see basically the U.S. Peaking at a 16% rate. It drops off a little bit. But that's a very different picture of the economy and what's going on at this time period versus the overall employment rate. So if you are a young person in the United States, you're looking for a job, you see a very, very different picture, basically an unemployment rate that could get as high as 15 or 16% compared to half that, 7%, for the overall working population. So it's a very different picture. And we can make those comparisons as we've done before across the board. It appears Luxembourg, Netherlands, Malta equivalently are managing their youth unemployment rates a little bit better than the United States. But then when we get into France, Estonia, and sort of reading across through Greece and Spain, we see that the management of the youth unemployment rate across that spectrum is really, really poor, and probably accounts for some of the unrest in those countries. Particularly if we look at Greece and Spain, the picture looks very, very bleak there for youth employment, with the unemployment rates exceeding half the population in that age category. Now, one of the things that I want you guys to get out of this is how effective these small multiples can be when you have a comparison. So here, all of these small multiples are comparing to what's going on in the United States. And this is, the United States is sort of utilized as the mean that's going on here, or what the comparable is. This type of data could also, let's say it's not for a U.S. audience, this is for, let's say we're creating these for a European audience. Instead of using the U.S. as the light gray comparable, we might take an average, basically the mean of all these countries, and we might compare each of the countries to the mean line. Now, we also have this problem of overplotting. So the problem of overplotting is when we've plotted so many data points that it's very difficult to see what's going on. So if we look here on this particular visual frame, we can see on the very center, sort of the bottom left center of this particular visual frame, we've plotted so many points that we really can't tell what's going on with a lot of the data. And so this, of course, is a problem because our objective in data visualization is to see what's going on in the data. Now, the technique of small multiples can help solve that problem by improving the visibility. So this set of 4 views presented on screen is the exact same data set that we were just looking at. So we have all of this data, but we've separated it into 4 different views. And when we do that, it improves our visibility. So we can see for these different variables, we can see what's going on in a lot more detail because we don't have as much overplotting. And in this particular example, it's a sales example that has different sales regions, but the principle is true regardless of the data that we're utilizing. If you run into an overplotting problem, often the solution is to create a screen full of small multiple comparison. So here we have presented our multiple view decision matrix. And so what this is designed to do is sort of be a guide toward what do I use when, what's available, etc. And so the 2 different major axes here in our matrix are what type of data do we have, and then what type of encoding do we have. And so if we'll start here, first place we might start is we want to represent a subset of data. If our encoding is the same, the right answer here would be an overview with detail with the same visual encoding. If we move over and take a look at representation of data, and then with the same encoding here, we're presenting small multiples. We have the same encoding with these smaller little views or frames presented side by side. Then if we want to look at all of the data with different encoding, we are looking at multi-form visualization. So we have 2 different forms side by side here. If we want to look at a subset with different encoding, so we have multi-form with overview and detail. So the overview is one type of encoding and the detail is another type. And then if there's none and different, there's really no linkage there. Basically, that cross-section would simply be a statement that, okay, we've created a couple of different visualization frames. And so there's no real linkage between the two. Now, linked highlighting. So linked highlighting is a technique where we can create multiple frames of data visualization. We can put them in the same view. So for example, a dashboard, perhaps in Tableau or another tool set. So we have several data visualization views that we put in the same frame. And the selection of one of those views becomes a filter or highlights another view. So what we see represented here, so on the left-hand side, we have some different variables for baseball players. So here we have years, so the years that they've played. We have salary next to it, so a logarithmic scale of their salary. Number of assists that they have, number of hits per year in each of the years, and then at the bottom, the position that they played. And what we're representing here is that the selection of one of these, for example, we might select years, that might affect or filter the other views. So providing an example here, we might have a selection. So you see the circle of one here. So we select a particular type of salary, and that restricts the data set. And we see, for example, in assists, hits per years, we're only seeing certain data elements highlighted in the yellow that correspond with that salary level. And that's represented in each of the visual frames. Similarly, if we look over on the right-hand side, so we may have a particular interest in the number of assists. So we want to look at all players that have a certain number of assists or higher. So a certain measure range in one variable called assists. So we select that range, and then that also restricts what we're looking at in terms of salary, as well as the number of hits per year, as well as the positions played. For example, that might give us some insight into, okay, these folks had the number of assists, sort of our targeted range of assists, but that's only going to include players that are in these four unique positions, playing in these four unique positions.